To learn about the whole system working, we must know the system components. So let's have a deeper look of it. Now there is a mean flywheel system, a chain and sprocket system, which is used for the transmission of kinetic energy from rear wheel to main flywheel system, and from main flywheel system to the rear wheel system. Now this chain sprocket system consists of a smaller sprocket which is of 13 teeth, and a larger sprocket which is of 41 teeth, and this larger sprocket is connected rigidly with the rear wheel with the help of some bolt and nut and washer. Now, coming to the mean flywheel system, it consists of an axle rigidly placed on this modified frame with the help of some screws and connectors, and this modified frame is rigidly connected with the mean frame of the system to give the support to the mean flywheel system. Now, this mean flywheel system includes the chief element of the flywheel. Now, this flywheel is nothing but a massive plate of heavyweight. Now this flywheel has a mass characteristic value on the virtue of which it stores the energy in the form of kinetic energy and releases it when required. Now there is a flange which is rigidly connected to the clutch plate with the help of some screws and adhesive materials. Also there is a sprocket with there is the small sprocket which is rigidly welded with the flange. Now there is a cam designed for the movement of this whole clutch plate and flange so that the clutch plate gets engaged to the flywheel. Now to support the cam movement, there is a spring, brake wire and a lever. Also we can say that this is a clutch wire because it applies for the movement of this engagement and disengagement and not the braking. So now when I will press this lever, as you can see, the spring will help the cam to move this flange and clutch plate arrangement in the forward direction towards the flywheel, so that the clutch plate gets engaged to the flywheel and transmits the motion from rear wheel to flywheel. And now when I release this lever, the clutch plate and the flange will move backward to its original position. Now let's see the working of this whole system. Okay, so now let's get the cycle work. Okay, so now I will pedal the cycle, and as you can see, the flywheel is not rotating. And when I press the lever, the plate gets engaged to the flywheel and transmits the motion to the flywheel. And now I'm going to release this pedaling or stop, and now I will apply the brakes to stop the motion of the, and as you can see, the flywheel is rotating on the ball bearing, and I will apply the clutch again, and as you can see, there is a small push or boost or an acceleration provided to the pendle with the help of this chain and sprocket system. So in conclusion, we learn that if this system is applied in the bicycles, the movement gets convenient after reducing the speed. When we want to increase the speed after reducing the motion, this system helps in the smooth movement of the pedals. So now also we conclude that if the improvements in these designs are made, the efficiency and the effectiveness of the system can be increased. So for example, if this clutch plate arrangement is replaced with a two sprocket system, the system gets more effective and the efficiency increases. So also the system can be improved by using some electromechanical arrangement, using some PCBs and boost button and some batteries. So we conclude that this system can be improved if some focus is if some focus is made on